Hello everyone, I welcomes you all for the session of Worm Gears Part 4. Before proceeding with this video, I kindly request you all to go through the first 3 videos of Worm Gears. The objectives of this video is to understand the design of worm gear drive, to discuss the design of worm drive based on strength, wear and thermal consideration. So first we'll talk about worm gears. It is having the pair of worm and worm wheel. Worm is threaded screw and worm wheel is tooth gear. So threads and teeth. Now comparing in between these two, threads are more stronger than the teeth. So worm wheel is considered as a weaker part. So as we know that we design based on the weakest section. So design is based on strength of worm wheel according to Lewis equation. Lewis is the scientist who have given the design of spur, helical bevel and worm gears. Now there are two types of failure in the teeth of gear. First is bending failure and the wear failure in the tooth. Bending failure is due to both the failure basically are due to the tangential load. This wear failure is also called as fitting failure. Now our design is based on, for bending failure, the design is based on beam strength rating. To overcome this bending failure, we have to go for beam strength rating. To overcome the wear failure, we have to go for wear strength rating. And as we know that there is more friction, or there is a maximum friction in case of worm gear drive as compared to the other gear drives. So thermal consideration is an important topic to be considered under worm gears while designing due to its high heat generation. So now first we'll start with strength rating of worm gear. That is nothing but beam strength rating of worm gears for bending failure. Now basically, what is beam strength? So beam strength of the gear tooth is nothing but the maximum permissible torque that the worm wheel can withstand without bending failure. So this is the formula for torque. There are the two formulas, MT1 and MT2. This MT1 and MT2 is nothing but the permissible torque on worm wheel. It is the permissible torque on worm wheel. There are the two relations to find out the torque. First relation is by considering the effect of worm, and second relation is by considering the effect of worm wheel. So torque acting on worm wheel. So both are the torque acting on worm wheel. So by using these two formulas, we have to calculate these two values. Now here the formula is 17.65 into XB1 into SB1 into M LR D2 into cos gamma. So XB1 and XB2, these two are nothing but speed factor for strength of worm and worm wheel, whereas SB1 and SB2 bending stress factor of worm and worm wheel. So this X depends on speed and S depends on stress. Okay, so and M is module, where LR is nothing but the length of root of worm wheel teeth. Length of root of worm wheel teeth. D2 is the diameter of worm wheel. D2 is the diameter of worm wheel, and gamma is nothing but the lead angle of worm. So by using all this, or by finding all these parameters and substituting in this formula, you will get MT1 and MT2, and out of this, whichever is lesser, you have to use it for design purpose. So we'll see how to calculate. Now in this, basically, first we will start with XB1. So speed factor for worm gears for strength. Now speed factor depends upon revolutions per minute. So if suppose you are finding xb1, so use n1, and xb2 you have to use n2. N1 is the speed of worm and n2 is the speed of worm wheel. So if suppose 1000 is the n1, then you have to go with this vertical line. The point of intersection of this 1000 line and the curve will give you this, will give you on y-axis as speed factor. This point of intersection will give you the, sorry, not point of intersection, the horizontal line drawn through the point of intersection and intersecting at y-axis will give you the speed factor. Similarly, you have to go for xb2. Now, next is we have to calculate about, or we have to find out SB1 and SB2. Now, we are knowing the material of worm and worm wheel. So, the material of worm is, it is case hardened steel, and whereas for worm it is, sorry, for worm wheel it is phosphorus bronze. So, when we are talking about worm, so you are having the this much possibilities. There are so many materials, out of which whatever is your material, based on that you have to select the value of SB. If suppose your material is case hardened carbon steel with 10C4 and 14C6, then your SB will be 28.20. Now, similarly talking about worm wheel, it is phosphorus bronze, and what type of manufacturing process is used to manufacture the worm wheel, based on that they are classified: centrifugally cast, sand cast and sealed, and sand cast. This process you have already learned in manufacturing process. So based on that SB value you have to select. So basically SB is nothing but the stress factor. So stress, it depends on material, so you can remember in that way. Okay, and next is you have to find out module. So from where you will get module? By this equation. And how you will get this equation or this fundamental values? By knowing the center distance and by knowing the transmission ratio or speed ratio. If your transmission ratio is 20 and center distance is 200, then this will be your fundamental values and 8 will be your module. This we have already discussed in previous videos. Okay. Then next is you have to find out LR, L suffix R. That is the length of root of worm. It is given by this formula, in which DA1 is nothing but outside diameter of worm. F is effective face width of worm wheel. It depends on formula twice m under root of q plus 1, where q is diametral quotient. So in this it will be 10. Then C is nothing but clearance between the two, worm and worm wheel. So that is 0.2 m cos of lead angle. Next is how to find lead angle by using this formula. Tan of lead angle is given by Z1 by Q. And once you have got all these values, you will substitute these values in the equation of MT. Then you will calculate MT1, MT2, and whichever is lesser, that value you will use in this equation of, in the equation of Kw. That is 2 pi n MT upon 60 into 10 raised to 6. Next, we'll talk about wear rating of worm gears. So, wear strength. Basically, same definition is over here. Maximum permissible torque that worm wheel can withstand without fitting failure. In previous definition, it was maximum permissible torque that the worm wheel can withstand without bending failure. Now again there are two formulas, MT3 and MT4. Now MT3 is 18.64 XC1 SC1 into Y suffix Z into D2 raised to 1.8 into M. So here again MT3 and MT4 are nothing but permissible torque on worm wheel. XC1 and XC2 is speed factor for wear of worm and worm wheel. SC1 and SC2 surface stress factor of worm and worm wheel. Again it is a stress factor based on surface stress factor actually. In that it was a strength stress factor. Okay. Now surface stress factor, why? Because here there is a contact stresses. The C stand for contact stresses between the worm and worm wheel. Then YZ, it is a zone factor. And D2 is the diameter of worm wheel and M is module. So in this equation, D2 we are knowing it by fundamentals. You can find out D2 and M is the module. That it is a fundamental value. So in this you have to find out these three values. Again, out of MT3 and MT4, whichever is lesser, that we have to use for finding the power. So now first we will see speed factor for worm gears for wear. So this chart is used for it, that is XC. Now this depends on rubbing speed, which is given by V suffix S, and revolutions per minute, that is N1 N2. Okay, now for worm, if suppose you have to find out XC1, then and your rubbing speed is 10, so this will be the line of 10, and at the same, now you have to consider, sorry, okay, we will see for 20, this will be the line of 20. Then if suppose it is 2100, so here it will intersect, it means it is in this region, so the value of XC will be 0.07. How to find this? I will elaborate it more while solving numericals. So this is a method to find XC1. Similarly, you can find XC2. Vs will be constant, but simply speed will vary. So N2 will be, suppose N2 is somewhere over here, 200. So this is the line of 200. So this is the point of intersection. So you have to see for nearest curve, this is the nearest curve, 0.1. So that will be the value of XC2. Now talking about surface stress factor, that is SC, SC1 and SC2. Again, materials are given over here. Materials of worm and worm wheel we are knowing, and based on that materials, we have to select the subsequent value. Then how to find YZ, that is zone factor. So for this you should have two values, Z1 and Q. So both the values are fundamental values. So if you are knowing this two, then if suppose your Z1 is 2 and Q is 9, so this will be your YZ. So again, after this you have to use same formula of Kw, which we have seen in case of beam strength. That is twice pi n mt upon 16 to 10 raised to 6. In that mt you have to use, that is whichever is lesser one. So that will be power transmitting capacity under wear strength. So next is thermal consideration. Efficiency of the worm gear drive is low, and as we know that high friction is seen in worm drives. So the work done by the friction, whatever work done is by the friction, that is converted into heat. And when the gear drive is in under operation condition, considerable amount of heat is generated. So heat generation, or the rate of heat generated, that is given by H suffix G, that is in watts, is given by the formula, that is 1000 into 1 minus efficiency into power, that power is in kilowatt. So this is your equation number 1. Now at the same time, as there is a heat generation, and this heat generation is not feasible for the gearbox, we are using lubrication oils and we are providing some fins. So some amount of heat is dissipated to surrounding by means of lubricating oil and fins. So the rate of heat dissipated in watts, and it is represented by HD. It is given by HD equals to K into T minus T0 TO in bracket A. Now this, where K is overall heat transfer coefficient of housing walls. Overall heat transfer coefficient. It is in Weber per meter square degree Celsius. So the value is 12 to 18. K is 12 to 18 for natural air circulation, and it is 20 to 28 for forced air circulation. Forced air circulation means if you are using fan or if you are using fins, then the circulation is more. Then the heat dissipation is more. So in that case, overall heat transfer coefficient you should use in between 20 to 28. Then T is the temperature of lubricating oils in degrees Celsius. TO is the temperature of surrounding air. Then A is the effective surface area of housing through which the heat will be dissipated. So these two are the equations, rate of heat generated and rate of heat dissipation. Now for ideal gearbox, what we will say, rate of heat generated, it should be equals to rate of heat dissipation. So equating equation 1 and 2, Hg is equals to, Hg is equals to Hd. So from this we can derive the formula of power, that is K into T minus TO into A upon this term 1000 into 1 minus efficiency. So this is nothing but the power transmitting capacity based on thermal consideration. And by rearranging this equation, we can achieve the equation of T, that is temperature of the lubricating oil. So by knowing this, we can easily select the while designing, by finding this temperature, we can easily select the lubricating oil. So this is the formula for it. So this is the temperature of lubricating oil for given power transmitting capacity. And the maximum permissible temperature for commonly used lubricating oil is equals to 95 degrees Celsius. Thus how we have finished the design procedure of worm gear drives. If you are having any doubts, please note down and comment. And if you have liked my video, then please like and subscribe it. Thank you.